morning, everyone. I'm Yuxi from Shanghai Jiao University. Today, I will be presenting the topic of response of diurnal air temperatures over different land use to extreme heat events. Okay. In recent decades, extreme temperatures has caused serious concerns. News has reported millions of deaths due to this extreme event. In the year 2022, more than 61,000 people have died in the European heat wave of 2022, including over 3,000 deaths in the UK. This continuing increasing temperature interact with the urbanization process, such as the human-induced land use and land cover changes, the altered wind speed, and the anthropogenic heat and moisture emissions. These human-induced changes further warm up the city core and causing issues such as the urban heat islands and intensified extreme heat events, further impacting the human health and comfort. However, how these human-induced land use and land cover changes interact or changes with these extreme high temperatures remains unclear. Thus, we attempt to investigate how these land use land cover types respond to heat waves, and how does different urban areas respond to heat wave, and how do these effects impact human. To solve these problems, we wanted to investigate the temperature changes during heat waves and non-heat wave days in each type of land use land cover types. So we firstly employed the integrated surface climate data set, which is short for the ISD-like data set, which is developed by the National Climate Data Centers. And we employed the data for the year 2022. And the data was recorded by the real weather station worldwide. And after we obtained the location of the weather station and the climate data, we assigned the land use land cover data to each station in the accordance to the ESI ACCI LULC map in a resolution of 300 meters. Also, we also assigned the building volume data from the 3D building density data from Lee et al. 2020s. And this map is in a resolution of 1 kilometer square, not 1 kilometer, 1 kilometer square. For these reasons, we attempted to present the urban form in a 3D way. So we use this 3D building data. After we assigning all these characteristics to the stations, we then use the temperature, the climate data from each station to select the heat wave and non-heat wave days data from each station based on these definitions, which are obtained from previous literatures. Then we have all the climate data during heat wave and non-heat wave days. Then we use the fast Fourier transform to produce one heat wave and one non-heat wave daily temperature cycles, and then we can subtract these two to obtain the changes in daily temperatures due to heat waves, and we did that for each stations. Due to data availability, the final section include the station located in the Europe and China for us to analyze. Then we compute the changes in the changes in mean temperatures due to heat waves in these three types of land cover. Surprisingly, the increase in temperature due to heat waves in cropland covered area is the least severe, while the tree covered areas and the urban covered area shows the similar higher increase in temperatures. Then we look into the daytime and nighttime temperatures. Similar patterns were observed that the temperature changes in cropland area were significantly lower than the other two. While this effect is more significant during nighttime than during daytime, because we can see that the difference, uh, the difference among the three land use and cover types during the daytime is smaller. Um, we suppose that this reason why the uh, tree cover areas shows the larger increase in temperature, maybe because uh, the tree in our definition of tree cover area in this study, the tree cover area only consists of natural vegetation in a mixture of broadleaves and needle-leaf trees, which may cause limitation of wind speed to cause a warming effect. Also, we think that maybe the irrigation activities in cropland produce an extra cooling effect. Then we try to find a relationship between urban building volume and heat wave effects. But obviously you can see that there is no linear relationship. But we do see that the distribution in Europe and China are different, which may indicate that we need further investigation and maybe incorporate other variables to this evaluation. Although we did not investigate significant trend in the groups of urban areas, we can still look into individual cities. Here, we compare the diurnal temperature between urban area and their surrounded cropland area or tree area separately. We can see that during heat waves, the urban area and their surrounded tree area shows different behaviors. The heat wave tend to uh, present or produce or show a daytime cool islands which does not exist during normal days. And the heat wave also intensified the nighttime heat island effect by 0.16 degree. Also different from the tree cover areas. The urban area covered surrounded by cropland areas shows an intensification in both UHI and UCI effects that these two effects already exist. Then we want to take humidity and wind speed into consideration. So we calculate the apparent temperatures. The patterns between urban area and their surrounded tree areas were similar, is showing the daytime cool island and intensifying the nighttime heat island intensity. But the absolute amount was higher than the temperature. But different from the temperature results, urban area and the surrounded cropland areas shows a daytime cool island which does not exist during normal hours and amplified existing nighttime heat island effects. In conclusion, because we observed the tree covers to might increase by a similar amount as urban area during heat waves, we think that the mitigation effects of tree covers to warming effects may be limited in some areas, but this conclusion is only based on the very definition that used by the land cover map we use in this study. Also, the cropland areas may provide cooling effects, maybe due to irrigation, or it may be due to some studies shows that it may be due to the lower albedo rate. Also, the different urban form may respond differently, and using parameter differently also may lead to different results. These results highlight the importance for us to employ multiple parameters. And the limitation in this study include that some of the weather stations may not located in the urban core. Some of them might located in the airports, etc., but still classified as the urban station, which means that this station may not fully capture the human activities. Also, the influence of the background climate also need to be considered during evaluation. And that's all. Thank you very much.
Thanks, Yuxi. A very well-timed talk as well. Thanks for that. Any questions for you? I want there first.
Thank you for your very nice talk. My question is, what's your rationale to compare the cooling benefits of trees for China and European areas? What's the rationale? To me, probably if you're talking about the impact of background climate to the cooling effects, probably that's more straightforward to understand. Now, if you refer to kind of areas to reach to greens, seems not the rationale behind the study is not clear to me.
So in this study, we tend to do the test in these two regions separately and see if there's any different patterns. We're not really comparing them together. We might observe a phenomenon that exists in Europe, but we're not observing it in China. So I think that's how we perform the test.
Okay. Matt, you have a question.
Thank you very much for your presentation. In general, we know from literature that during heat waves, the intensity of urban heat island is increasing in most of the places. And this has to do, let's say, with the evaporation in, let's say, the rural areas and urban areas. Because in the rural areas, you have more, let's say, humidity, so humidity, you have more evaporation. So you have, let's say, the drop of the temperature compared to the ambient temperature. At the same time, during heat waves, advection is low, but is important. So I'm a bit surprised to see that you have generalized without really taking into account the effects of, let's say, condensation, that can be very important, and the effects of, let's say, advection, for example. You have considered Athens. Athens is very much, let's say, influenced by sea breeze. So you cannot really compare the regime in Athens, because the impact, of urban heat island, or the reasons of urban heat island, are completely affected by advection. So a generalization of this phenomenon, it's a little bit risky.
So that maybe the characteristics that you're going to explore will help to unpack that, the difference in characteristics.
Yes.
Right, how are we doing for time, Paul? Got time for one more question? No? Okay, thanks a lot, Yuxi.
Thank you.
Okay, and our final